Ever wondered how machines make decisions? Like humans, they also use a strategy. One such strategy is called decision trees in machine learning. Imagine a tree with branches spreading out, each branch representing a possible decision, outcome, or reaction. Now imagine this tree in the world of algorithms and data. That's a decision tree. Decision trees play a pivotal role in machine learning, a subset of artificial intelligence. They are used for both classification and regression tasks, simplifying the complexity of decision-making for machines. Essentially, they break down a dataset into smaller subsets, while at the same time developing an associated decision tree. The final decision is reached by performing specific actions, represented by the tree branches, and evaluating the results. The beauty of decision trees lies in their simplicity and visual appeal. They are easy to understand, interpret, and visualize, making them a popular choice for machine learning, beginners and experts alike. So, intrigued by how decision trees help machines make decisions? Stay with us. Imagine you're playing a game of 20 questions. You ask yes/no questions to guess what the other person is thinking. That's how a decision tree works. A decision tree is a flowchart-like structure in which each internal node represents a feature or attribute. Each branch represents a rule decision, and each leaf node represents an outcome. The topmost node in a decision tree is known as the root node. It learns to partition on the basis of the attribute value. It partitions recursively in a manner called recursive partitioning. So how does this relate to our game of 20 questions? Well, each question you ask is like a branch in the tree, leading you closer to the answer based on the response. Each possible answer is a leaf node, representing a possible outcome of the decision-making process. Just like in our game of 20 questions, decision trees use a series of yes/no questions to reach a decision. Now that we understand the structure of a decision tree, let's delve into how it works in machine learning. Imagine you're navigating a maze. At each junction, you have to make a decision. Left or right, forward or backward. Each choice brings you closer to the exit or sends you spiraling back to the start. This is how a decision tree works in machine learning. It navigates the maze of data, making decisions at each node or junction based on the information it has. But how does it decide to make these decisions? This is where the concepts of entropy and information gain come into play. Entropy, in the context of decision trees, is a measure of the impurity or disorder within a set of data. Imagine a bag of marbles, all different colors. If all the marbles are the same color, the entropy is 0 because there's no disorder. But if the marbles are all different colors, the entropy is high. Information gain, on the other hand, is a measure of how much information a particular feature or attribute gives us about the final outcome. Going back to our marble example, if we know that the marble we're looking for is blue, and half of the marbles in the bag are blue, that information gives us a significant advantage, and thus has a high information gain. In decision trees, the attribute with the highest information gain is placed at the root node. The tree then branches out with other attributes, each node representing a decision based on the attribute's value. This process continues until all data is classified, and we reach the leaf nodes, which represent the final decision or prediction. So, in essence, a decision tree is a series of questions, each question dividing the data further and further until it reaches a conclusion. It's a systematic, logical process of elimination that allows the algorithm to make the most accurate predictions based on the information it has. So, a decision tree uses a series of questions to guide it to the most accurate predictions. It's like having a roadmap to the best decision. Like any other algorithm, decision trees have their strengths and weaknesses. On the plus side, decision trees are straightforward to understand and interpret. They mimic human decision-making processes, making them relatable for us. They can handle both categorical and numerical data and require little data preparation, adding to their versatility. However, they are not without their limitations. One of the most significant challenges with decision trees is the tendency to overfit, especially with complex trees. Overfitting means the algorithm performs exceptionally well on the training data, but not so well on new, unseen data. Another limitation is their susceptibility to bias if some classes dominate. It's a classic problem of the majority overshadowing the minority. But don't fret, these limitations can be mitigated by techniques like pruning and balancing the dataset. Despite their limitations, decision trees remain a powerful tool in machine learning, providing a simple yet effective way for machines to make decisions. So, decision trees in machine learning, simple yet powerful, right? We've delved into the structure of these trees, their nodes and branches representing questions and answers. We've seen how they operate, sorting data into increasingly specific categories. Plus, we've explored their strengths, like interpretability, and limitations, such as overfitting. Remember, like in any decision-making process, the key to using decision trees effectively is understanding the questions to ask and the criteria to consider. Until next time, keep exploring.